So this week we're going to look at systems of equations and solving them by graphing. So if you haven't seen these yet, system of equations is just two equations, and that's it. So if you have two equations, you have a system of equations. If you have 3, 4, 5 equations, that's also a system, but we only do two equations. So to solve these by graphing is really not much different than what we've done before. We're just going to graph each of these. I'm going to rewrite that in red actually. So y equals x plus 2. So I'm going to graph both of these lines and then talk about solving them afterwards. So the line y equals x plus 2, I'll graph that one first. So I would have an intercept of 2 and a slope of 1. So let's see if I can put this in the right place, and there we go. So that is y equals x plus 2. Y equals 2x plus 2 is going to go through 2, and it's going to have a slope of negative or positive 2. So we just have a slope of 2. As soon as I can adjust that. Okay, so that's roughly where it is. Now, if you just zoom in, you can see those are going to intersect at the point right here. So that is the solution. So where two graphs intersect, or two lines intersect, that's going to be your solution. So the solution here would be, this happens at x equals 0, and the y value is 2. So we put this in coordinate form. So this would be the point 0, 2. So this would be the solution to that system. So again, a system of equations is just two equations. The solution is where they cross. Okay, so in our next example, we have two lines, same thing. We have a system, so let's graph those. So 1/3 x plus 1 will be in red. So that has an intercept of 1 and a slope of 1 over 3. So up 1 over 3, up 1 over 3. And I don't need all these. It just helps me guide the line that I'm going to put there. So draw the line. Make sure it goes through all those. Okay. Now the blue line, negative 7/3 x plus 9. That goes through the intercept, y-intercept at 9. And then from that we go down 7 over 3. Down 7 over 3. And then we draw our line. And you can already see where it's going to cross probably. And so line those points up. That one crosses right here. So then you just have to take that coordinate point. So that is the coordinate point xy. So it's over 3 up 2. So the solution for that is over 3 up 2. And that is our intersection point. So this is the point 3, 2 as a solution. Okay, so this one, notice it's set up a little differently. That second equation is anyway. So let's go ahead and I'll just change the color on that one. Okay, and I'll graph the blue line first because that's already set up. So 2x plus 2, there's the intercept, then it has a slope of positive 2. So up 2 over 1. Okay, so for the second equation, we're going to have to solve that for y first. So what I'll do is divide everything by 2. Divide by 2, divide by 2. And then I would get y equals 2x plus 2. Well, that's the exact same line as this. So if I draw that right on top of it, and there you go, it's right there. So what is it? Well, it's the exact same line. So how many solutions does it have? How many times does it go, intersect the other line? And it intersects everywhere. So this is an example where the solution is actually, we can say infinite solutions. That's what I would usually say. So this system of equation has infinite solutions. So it intersects absolutely everywhere. Okay, so let's look at this one. I will again change the color of this. Okay, so y equals 2x plus 1, y equals 2x plus 5. I will graph the blue line first, so it goes through 1 and it has a slope of 2. So put my points up 2 over 1 all the way down. Okay, draw the line. There it is. And then y equals 2x plus 5. That goes through the intercept at x equal, or y equals 5. And then it has the same slope. Okay, so position the line there. And you can see what is the solution. Well, those are parallel lines. So the slope is the same, so how many solutions does it have? Similar to the last problem where it's kind of a weird, solution, infinite solutions. This one, parallel lines don't cross, so this has no solutions. So the solution to the problem is that the problem doesn't have a solution. So that's a system that those are parallel lines. So those, between the first two examples and these two examples, those are the three different types of answers you'll have in these. Okay, so we're going to look at just one story problem. So it says, I have $10 and save $10 per week. You have $25 and save $5 per week. When will we have the same amount and how much will it be? So we have two equations here. We're going to have one from that sentence and then two from this other sentence. So we have equations for each of those. So the first one, I have 10 and save $10 per week. So like I said before, if it says $10 per week, that's telling you that the 10 goes with your variable x, and you start with 10, and you can see it's an equation with 10x plus 10. That would be I. And you have $25 and you save $5 per week. So you have two equations right there. So this is very similar to the last problem. I am going to change the scale on this graph a little bit. So I will say each of these is equal to, I'll say each one is 5. So let's go by 5s. 5, 10, 15, 20, 25, 30, and so on. So I really don't need all these numbers, but that's fine. I'm not going to change the x-axis because the numbers aren't as big. So yeah, so I am in red, so 10x plus 10. So that's going to start on 10. And then the slope is 10, so that's up 10 over 1. So I would go up 5, up 10, over 1. And I know on this, the way that I changed the scale, it makes it look like it has a slope of 2. And that's completely fine. You won't have to do this on your homework. You will just, since they're digital, you don't have to worry about it. So you have $25 and you make $5 or save $5 per week. So I go to the 25, put that there, and then your rate is $5 per week. So that's going to be up 5 over 1. So from 25, I just go up to 30, then over 1, then up to 35, and then over 1, then up to 40 and over 1. So you can already see our solution because that's where the lines cross. And something like that. So the intersection point is the solution. So let's answer the questions. When will we have the same amount? Well, these are going by ones. So it'd be 1, 2, 3. And these are the weeks. And this is the dollar amount up here. So when will you have the same amount? This would be at week 3. And how much will it be? Well, that's the y-axis. That would be $40. So there are a couple like that in the assignment as well.